and a warm welcome to you. Thanks for coming today to help organise and prepare for the delivery of the 2023 Data Science course for Year 10 in Term 4 this year. Our goal is to create a concise and engaging course that will be effective and informative for all our students. The design of this course has been built around the principles of cognitive science and load reduction. And so I'll just go through the top principles now and we'll reinforce what they are as we go through the talk. So the first is to reduce any unnecessary distractions of the material that we prepare and chunk the learning sequence into discrete portions so that it's able to be able to be grasped into long-term memory and processed. And by appropriate ordering of information, allow students to perform high-level thinking to reason about information in terms of the key outcome of transforming any learnings into long-term memory. And in doing so, just go through a process of ensuring the students are motivated and they're achieving outcomes throughout the course and they're emotionally achieving what they want to achieve. And with that, having a structured approach to constantly assessing where the students are up to make sure that we know where they're up to at any given time and they don't have into the situation, which I'll cover in a second, of cognitive overload. So now data science is the science of turning data into evidence. We conduct scientists will make a hypothesis, conduct an experiment and collect data. But that needs to be transformed adequately into evidentiary situation. And to then go further, we have to be able to communicate and explain what that information is to a range of audience to make the case compelling. And for that, high quality visuals are key. And as you can see here, this is the example where John Snow was able to make the invisible visible by highlighting where the cases of cholera were found in 1854 and mapping against that the different wells around the area, so it became quickly apparent which was the infected water well. So what does a cognitive instruction approach means? It means that what we're doing is recognising physically how students sense the environment either through sight, sound, touch, sense, and it enters the brain, and if the attention is correct, then enters into their working memory, from with which, if they've got a grounding, if there's a form of grounding in long-term memory, and they're able to process that and then transform that into learnings, hopefully in long-term memory. So our job, therefore, is then to design the instructional material and the methodology of how we're doing it so that this can take effect. So, for example, and the way we can do that is by having clear definitions of what information is and how it's actually communicated. So a key mechanism here is the mathematical formalism of a graph, where we have nodes and edges and how these things relate. And graphs are important because not only are they great for defining precisely content, but they allow us to, it also represents how data is stored within the brain in the form of synapses and neurons, to have a graph of information cognitively. Now, if we look at this notion of cognitive overload, whilst one can assume that we might have infinite capacity for long-term memories, in practice our working memory is quite narrow, and that it processes information in chunks. So what we need to be able to do is ensure that, first of all, information arrives into the brain, which is why you've got to keep the content low, and to do that is minimising the improving signal-to-noise ratio, such that we want, it's a signal and not too much noise. So, for example, in a noisy room, if noise went up, you wouldn't hear what somebody was saying, and you reduce that down. So that's the principle of ensuring we're keeping things simple then. And then once you've got information into working memory, we need to then connect it to existing memories so students can start to reason about it. And this is where an educational knowledge graph is extremely important in that we can represent the syllabus and content to be taught explicitly in a directed fashion, and then also interpret the cognitive load and prerequisites as inputs to that to make pedagogical decisions. So just to give you an example of what that could look like. So here is an example of a thermodynamics educational knowledge graph, which is quite textual, but we can then simplify that fairly dramatically by having visualizations that show us the different curriculum elements of what they are, and then the different parts of the skills they exist, so we can then specifically measure and understand what level of skill the student needs to happen before you actually embark at that content. And so we can also look at other ways of communicating and having signal to noise management. So, for example, rather than just telling someone about thermodynamics, or you can get them to hold a sort of silver bar in this case, and they can feel what it feels like in the transition through to equilibrium to get that message across. And well, that has a great advantage of more deeply encoding the signal because it's unusual, it's not encoded, and you can see here this is the path of thermal information in someone's brain, and you can see it's quite extensive in terms of its encoding. And as you can see, the visuals are key to managing the storytelling aspect of it. So the data scientist with which I like to use in this course, and the textbook for the course is by Edward Tufte, and it's called Beautiful Evidence. And Tufte is famous for many things, such as his original book of explaining how Napoleon went through Europe. He's also got other papers, such as the cognitive style of PowerPoint, which you can see this type of approach is what we're not going to be encouraging in terms of an aesthetic approach to data science. And beyond these sort of technical and visual display, we've also got to realise that our students are people, and their emotions drive the learning. So we want it to be really clear that they're always confident. So that's why we've got to measure what they're going through here, making sure they're making progress through the course, and they're having accomplishments. And part of the use of visuals and maths allows us to mix teams up, so people with different skills, be they artistic or science-based, can contribute to developing persuasive arguments in terms of the process of turning data into evidence. Now, this is the knowledge graph for the course, and this is available to everybody in terms of being able to see the different parts of the syllabus in a connected and simple way, and the content we need to cover, and the level of understanding it needs to achieve in terms of its different prerequisites. So I'll make a link available for you here so you can navigate it and get a pretty good understanding of the actual course itself. And then furthermore on that, what I've done is packaged up the course so that we've got a full outline of the 30 lessons over 10 weeks for us to complete as we go along. And here we can navigate through the material that we need to prepare, and each part of this material has the subject covered, its level of its intended duration, its level of difficulty, and the outcomes in terms of its link back to the syllabus criteria of what we need to cover. So this is what we'll all be preparing, and you can see here I then have the break of the difficulties we go along. So and throughout the course it enters periods where it starts getting more complicated. So before we get to say what week 4, you can see here, we need to really make sure that the students have covered off the prerequisite information so they can safely understand what's going on in terms of their learning. And straight after that, as you can see, the cognitive load drops down a bit to, again, more graphs, and then getting to the point where we're starting to build up to a full scientific evidentiary argument in terms of a capstone presentation, which is something we need to work to throughout that there. So again, in terms of reviewing the material as we prepare it all, is just making sure everything is ordered and sequenced to make sure that students learn along, and we can then track student progress again with data in terms of how the course is. So again, thanks very much for coming today. If you have any questions, please just let me know what they are and we'll cover it right now. Thanks very much for attending today.